In this example, we want to solve the compound inequality 2x minus 3 is greater than or equal to 5, and negative 3x minus 4 is less than or equal to 5. So we have a compound inequality, meaning we want to find x values that will make both of these statements true, because we have the word and. And means we want both things to happen. Like if we think about this visually, like in a Venn diagram, the and is this part right here, that intersection between both pieces of information. We want, if I call one thing PlayStation owners, the other thing Xbox owners, the and means we want the intersection between these, so people who own both a PlayStation and an Xbox. We want x values that are going to make both statements true. So in terms of solving it, it's nothing complicated, it's just like solving an equation. And then when we get down to the actual solution set, that's where we have to start really making sure we understand what this means. So we're going to solve both of these inequalities. I'm going to add 3 to both sides, solving an equation. So I have 2x greater than or equal to 5 plus 3 is 8. And then solve for x, we're going to divide by 2. X is greater than or equal to 4. 8 divided by 2 is 4. So that's 1. Let's go ahead and solve the other one. I'm going to add 4 to both sides. I get negative 3x is less than or equal to 5 plus 4 is 9. Then I'm going to divide both sides by negative 3. Now when I divide by a negative, we're dividing by a negative across an inequality, what is going to happen here is we're going to flip the inequality. So this is going to be x is greater than or equal to negative 3 now. When we are, just a little side note here, let's say I had x plus 5 less than 7, something like that. If I'm subtracting like this, so I have to subtract 5, I don't have to flip there. The only time I have to flip is when it's dividing or multiplying a negative across that inequality. So you don't have to worry about it when you're adding or subtracting. It's just when you're multiplying and dividing. You want to make sure you're flipping that inequality. So here we have x is greater than or equal to 4. X is less than or equal to negative 3. So let's throw this onto a number line to identify what our solution is going to be. So x is, so here's negative 3, here's positive 4. It says x is greater than or equal to negative 3. So greater, I like to use brackets just to symbolize that my starting point, because we have greater than or equal to would be parentheses. But I like to just visualize it like this. So greater than or equal to, let me grab a highlighter here. Let me see if that works. It's not bad. Let me change colors. All right. So greater than or equal to would be all of the values going out this way. Greater than or equal to negative 3. So negative 3, negative 2, negative 1, 0, all the way out to infinity. And then let's do the same thing with the greater than or equal to 4. So from 4, we want all the values greater than or equal to 4. So that'd be starting at 4, going out this way. All the values greater than or equal to 4. So the problem, though, is asking the word and. It's saying what values of x make both of these statements true. So all the values greater than or equal to 4 and all the values greater than or equal to negative 3. So our solution is going to start right here, because this is the overlap. This is where they start to overlap. Our solutions overlap right here, starting at 4. This is not part of our solution. From negative 3 to 4, this is not part of our solution. This negative 3 to 4 makes this one true. This x is greater than or equal to negative 3, but it does not make this one true. In terms of like the intersection, where they both are true. So between negative 3 to 4 is not going to be a part of our solution, but from 4 out to infinity. So that means from 4 with a bracket, because we want to include 4. Remember, parentheses would be if we just had a strictly less than or strictly greater than. Use parentheses, but with those equal to's, we want to use brackets. So we want to include that value. So including 4 out to positive infinity. So all of the values going out here are going to make both inequalities true. So that's going to be our solution. And you could also write it as this, or if you want to just write it as this is fine too. X is greater than or equal to 4, but we usually write it into interval notation just to make sure we understand the actual values that make this true.